So now we will be proceeding towards the question number 3, which is how are polynomials represented in computers? Write an algorithm to evaluate polynomial and given with two respective parts, that is a. Compare the efforts in multiplication numbers and addition of brute force method with reoccurrence relation method, and B part, write the reoccurrence relation of dividing this polynomial by x minus r. So proceeding towards the answer, a polynomial p of x is an expression in variable x which is in the form of ax power n plus bx power n minus 1 plus up to ax plus a, where ax are the real numbers and x is a non-negative integer. N is called the degree of polynomial. Every term in polynomial consists of a degree and coefficient, and x is the exponent. We will obtain an algorithm to evaluate the polynomial equation. So, by evaluating the polynomial by a brute technique is simple but will involve n plus 1 by 2 multiplication and n addition. In the algorithm follows the number of multiplication reduced to n. The algorithm is based on following alternate method of writing the expression. So we are provided with three polynomial equations as it is shown on the screen. Further, we will be proceeding with the algorithm of the polynomial. So we are on step 1, read x n. Step 2, for I equal to 0 to n in steps of 1 do. Step 3, read ai and for loop. Step 4, an is initialized by p. Step 5, for I is equal to n to 1 in steps of minus 1 do. Where in step 6, ai minus 1 plus xp is initialized with p. Write p and stop. So the above algorithm explains that for loop set up by instruction 1, step 2 consists of only one statement, namely read ai. The statement read the array a0 a1 up till an, which is used to store the coefficients of the polynomial. The for loop set up by step 5 has only one step instructions. The algorithm traced here is, so we are provided with the three columns where times in loop I p. Times in loop refers to the values like 1, 2, 3 up to n. I is initialized as n for 1, n minus 1 for 2, n minus 2 for 3 till where n is equal to 1. So the following polynomial equations we get through the time and loops with respect to I. So here the above algorithm illustrates that in developing procedures for solving even simpler problems, a large amount of computation efforts may be saved by a slight reformutation of the problem. I hope you are clear with part A. Now we will be proceeding towards part B. Part B says that write the reoccurrence relation of dividing this polynomial by x minus r. We will consider the problem of dividing the polynomial where the equation is given and will be dividing it by x minus r, where r is a root of the original polynomial. The long division method is illustrated on the screen. As you can see, we are with the quotient a n x power n minus 1 plus a x a n minus 1 plus r a n, where x n minus 2. If we call the reduced polynomial given as b n minus 1 x power n minus 1 plus b n minus 2 x power n minus 2 plus up to b0, Then equating the coefficient of the above polynomial with the quotient obtained by division above, we get the following three equations. In general, bn minus I plus 2 is equals to a n minus I plus rb n minus I. Expression of this reoccurrence relation through algorithm. So, we'll be explaining this through algorithm of polynomial division, where the following 7 steps have been used. So the step 1 says for I is equals to 0 to n, in step of 1 do read ai, end of for loop. Step 3 says bn minus 1 is initialized by an. Step 4, for I is equals to 1 to n minus 1, in step of 1 do. Step 5, bn minus I plus 1 an minus 1 plus rbx minus 1, and for loop. For I is equals to 0 to n minus 1, in steps of 1 do. Step 6, write b, end of for loop, then stop. So through this, the above algorithm is very useful in reducing polynomials by removing the roots, and may be extended to cases where the polynomials is to be divided by a quadratic factor. So I hope we have understood the answer of question 3, and will be proceeding towards the answer 4 in the next video. Thank you.